This lesson is going to be on approximating square roots or estimating square roots, and we are on page 155 of your workbook. So there comes a time when it's necessary to approximate or estimate a square root, because as you guys know, not every number is a perfect square. And remember, a perfect square is something like the square root of 16 is a perfect 4, because 4 times 4 equals 16. Not every number is like that. So what we're going to be doing today is taking square roots of numbers that will not come out to be a whole number. So if you look at activity 1, okay, it talks a little bit about Archimedes, who is a Greek mathematician. He pretty much did everything. So what he tried to figure out, it says right here in activity 1, he tried to find a rational number whose square was 3. So the very first thing I want to do is define what it means to be a rational number. So somewhere on your page, wherever you have room, we're going to write a definition for a rational number. And basically, this is any number that can be written as a fraction. Okay? Any number that can be written as a fraction is a rational number. So right now, you may be having a hard time coming up with a number that can't be written as a fraction. So obviously, a fraction is rational. Any whole number, any integer will be rational. If you have decimals, for it to be rational, it either needs to be a repeating decimal or a terminating decimal, meaning it stops. Okay, so if you have like a repeating decimal, 0.333333333 and so on, that's repeating. It can be written as a fraction. It happens to be 1/3, so it would be rational. Or terminating. It stops at some point. If you have like 0.3, that's 3/10, 3/10. So any decimal that would go on and on forever and ever and never repeat would not be rational, and we call those irrational numbers. So if they're not rational, they are irrational. Okay, so if we look down at activity 1, part A, again, we're talking about Archimedes, and he's trying to figure out a rational number whose square is 3. So he tried these two numbers, 265 over 153 and 1,351 over 780. And they want to know on part A, are either of these numbers equal to the square root of 3? Okay, so if I pull up my calculator here, and first thing is I'm going to type in the square root of 3. Notice you get a really long decimal. Doesn't seem like anything is repeating, and obviously it never stops. It would keep going. So what I want to know is if either one of these fractions will be equal to that number that's created right there. So I'm just going to make a little note right in this box. The square root of 3 is 1.73205 080, and I'm just going to put some dots here because that would go on and on. So the first one I'm going to do is 265 over 153. You know fraction bar means divide. So on my calculator, 265 divided by 153. And you get 1.7320, but here's where it changes, 26143. So let's say the first 4 numbers after your decimal are the same, but then after that it changes. So this one would not be equal. It's really close, but it's not equal. And then let's try the other one. 1,351 divided by 780. 1.73205, but then after that it changes. So this one's not going to be equal either. So no, neither one of them are equal to the square root of 3, and I have my work up there to show that. So part B says use a calculator to approximate the square root of 3. Write that on a piece of paper. We don't need to do that because we already have it up here. And then square it, and then subtract 3. So I'm going to pull my calculator back up here. And I'm going to input the square root of 3 again. So there we go. And I'm just going to follow the directions. It says enter it in the calculator, which we have it. Square it. So here's my square button. You get 3. And then subtract 3. Do you get 0? Okay, now if we did that, if we were to approximate the square root of 3, if we were not to take that exactly, let's say we just did 1.7, okay? If I did 1.7 and square it, you get 2.89, and then subtract 3, you don't get 0. So unless you take the exact square root of 3 and follow these directions, you're not going to get 0 because we approximated it. We estimated it. So when we estimated it, no, we didn't get 0 because we estimated it. We estimated the square root of 3. Now, moving on down, part C says the value of the square root of 3 is between what two integers? So remember, we got 1 point something. So the square root of 3 is going to be in between 1 and 2. And D says, tell whether the value of the square root of 3 is between the given numbers. So again, I'm going to pull this calculator up. Move it down here out of the way. Square root of 3. Is it between 1.7 and 1.8? That would be yes. So just write a little yes underneath here. Is it between 1.72 and 1.73? So it is bigger than 1.72, but it's not smaller than 1.73. Notice it keeps going, so no. And then is it between 1.731 and 1.732? So 1.731, it is bigger than that. 1.732, but then it keeps going, so it's actually bigger than 1.732, so it is not between those two numbers. Okay. Then, activity 2, we're going to use this square. Part A, what is the length of the diagonal, this dotted line of the square? So, we've just been talking about the Pythagorean theorem the past few days. So notice I have actually have a right triangle right here. I know the length of this bottom is 1, and if it's a square, the side has to be 1. So if I use the Pythagorean theorem, I have 1 squared plus 1 squared equals c squared. That's the side I'm trying to find. Well, that's 1 plus 1 is c squared. So 2 is c squared. So the length of that diagonal would be the square root of 2. It's not a perfect square, so I'm just going to leave it like that. So that's the square root of 2. Now, on B it says copy the square and its diagonal on a piece of transparency. So you can do that on a piece of notebook paper. You can pause the video and do this really quick. But it says rotate it about 0. So you're going to keep 0 right where it is. And then you're going to rotate this down until your diagonal lines up with the axis down here. And you're going to use that to estimate about what number it would fall on. Now, if I did that, it's actually going to fall somewhere right in here is what you should have gotten, somewhere around 1.4 if you were to figure that out. So if we estimate the square root of 2, it's about 1.4. Okay, now we are actually going to jump down right here to page 158 where it says 7.4 practice. Okay, and you will be able to use a calculator for any of these that you are estimating, but this is going to be your assignment, this right here on page 158. So I just want to clear a few things up real quick. For numbers 1, 2, and 3, it says classify the real number. So all it wants to know is basically, are each of these rational or irrational? And you can refer back to the beginning of the video or the very first page to see the difference between those two. For 4, 5, and 6, it says estimate the square root. So this you could use your calculator to help you out with. But you're going to do it in two parts. You're going to estimate it to the nearest integer, so the nearest whole number, basically. And then for the second part, you're going to estimate it to the nearest tenth. And remember, that's one number past your decimal place, or your decimal point. And then for 7, 8, and 9, basically just which one is greater and explain. So you're just going to pick which number is bigger and then explain what you got. So you've got to be able to prove why one's bigger than the other. Okay, and then on number 10, you're talking about the velocity of a ball that's being dropped. So they give you an equation right here, and they want you to estimate the velocity. So they basically have it set up for you right here, and you just need to figure out what that would be and round it to the nearest tenth. So you just need to finish this page 158, do all of them 1 through 10.